Today we are going to start with a new lesson, that is ammonia, which comes under study of compound. It is the second topic after HCl. So first you should go through the HCl video which I have already forwarded. Then you may start with ammonia. Now ammonia is found in nature, in air as well as water, and it is a very important compound. It is used in the manufacture of explosive and as well as in the manufacture of fertilizers like urea and ammonium sulfate. That's also a fertilizer, and it has a variety of uses. Now this ammonia is basic in nature. Now Joseph Priestley was the scientist who produced ammonia first. He took sal ammoniac. Now what is sal ammoniac? That is ammonium salt, ammonium chloride with slake lime. Now slake lime is an alkali which is calcium hydroxide. So he took sal ammoniac with slake lime, and when he heated it, ammonia gas is released. Now look at this lab preparation of ammonia. So sal ammoniac, that is ammonium chloride with calcium hydroxide, when he heated it, you get ammonia. Now ammonia is collected by downward displacement of air. Okay, so it's collected by downward. Unlike HCl, HCl is collected by upward displacement. Alright, why is ammonia collected by downward displacement? Because it is lighter than air. Okay, now this is the drying agent used. The drying agent used is calcium oxide or quicklime. Now this quicklime is used because it does not react with ammonia, and the reactant over here is ammonium salt. Now usually you get ammonia from ammonium salt or from liquor ammonia. You know what is liquor ammonia? Ammonia in water. So now in this reaction, if you see this ammonium chloride, it's a ammonium salt. The ammonium salt are white solids, and they dissolve in water to give you ammonia gas. Okay, they are easily soluble in water. And over here we have used calcium hydroxide, slake lime. Now this slake lime, now we have to take in higher ratio. Why we have to take calcium hydroxide in a higher ratio than ammonium chloride? Because this ammonium chloride, now it sublimes on heating. When you heat ammonium chloride, it sublimes. You know what is sublimation? Turns from solid state to gaseous state. That's why calcium hydroxide is taken in a large quantity. Now calcium hydroxide is used because it is cheap and it's not deliquescent. You know what is deliquescent? We have studied in acid-base salt. Solids, when exposed to air, absorb moisture, turn into liquid state. So now this calcium hydroxide is not deliquescent, unlike other reactants. Okay, so that is why ammonium chloride and calcium hydroxide is used. Okay, now another thing is the flask. Can you see this flask in which this ammonium chloride and calcium hydroxide is taken? It's kept in a tilted position. Why is it kept in a tilted position? Because this water vapor which is formed in all the reactions, water vapor gets formed. That water vapor trickles back. Okay, if it's kept, this flask is kept in a straight position, this water vapor which is collected on top, it trickles back, it condenses. The vapors which are formed, water vapors, they condense back and come down, and they can damage this glass apparatus. That's why this flask is kept, the round bottle flask is kept in a tilted position. Now see how the gas is, ammonia gas is released from this when you heat it, and it's getting collected by downward displacement through this drying agent which is calcium oxide or quicklime. Okay, quicklime is the only drying agent used for drying ammonia gas. Can you name the drying agent used for hydrochloric acid? Just remember and let me know in the comments down. Okay. So now this drying agent is used because it does not react with ammonia. Any other drying agent, if you use, it reacts with ammonia. Like for example, if you take calcium chloride, it forms an additive product with ammonia. Just look at this equation. calcium chloride, if used, forms an additive product with ammonia. Ammonia plus calcium chloride gives you CaCl2 dot 8H2O. That's why calcium chloride is not used. Now the ammonia gas which is collected, how do you test ammonia gas? How do you identify ammonia gas? Now we can identify ammonia gas when you take a glass rod, dip it in HCl, and when it's brought near the fumes of ammonia, dense white fumes are formed. Okay, so we get dense white fume when a rod dipped in HCl is brought next to the fumes of ammonia. We had a similar test with HCl. Do you remember? In that time we had used glass rod dipped in ammonia. When it is brought next to HCl gas, dense white is formed. So same test is over here also for identification of ammonia. Now regarding the litmus solution, red litmus solution turns blue. Red litmus solution turns blue. This is the litmus test. Then methyl orange turns pink. Then phenolphthalein from colorless to pink. Okay, so that's how we identify ammonia gas. Now over here, many other ammonium salt can be used. See, there are ammonium sulfate can also be used, but ammonium nitrate is not used. Why is ammonium nitrate not used? Because it is explosive in nature. Okay, and itself decompose to form nitrogen and water. Alright, so that's why ammonium nitrate is not used. But any other ammonium salt can be used. Now look at this ammonium sulfate. When you take another alkali like sodium hydroxide, then ammonium sulfate with sodium hydroxide forms sodium sulfate plus water plus ammonia. Ammonium sulfate with calcium hydroxide gives you calcium sulfate plus water plus ammonia. Ammonium chloride with sodium hydroxide gives you sodium chloride plus water plus ammonia. So these are the other reactions. If you don't have ammonium chloride, then you can take ammonium sulfate, and if you don't have calcium hydroxide, you take sodium hydroxide, which is also a alkali. Okay, now ammonium salts are white solids soluble in water, liberate pungent smelling ammonia gas on adding with alkalis. Okay, now quicklime is used as a drying agent since it is basic in nature, does not react with ammonia. Did you get it, all of you? This ammonia gas is been observed whenever any dead and decaying matter decomposes in the absence of air or in the presence of air. Okay, now there are putrefying bacteria and ammonical bacteria which act on this organic compost or dead organic substances. Living putrefying bacteria and ammonifying bacteria, they act on this dead organic compound and release ammonia. Alright. Now this ammonia gas which is formed is collected by downward displacement because it is lighter than air, and second thing is not collected over water since it's highly soluble in water. Any other gas which you have studied before is highly soluble in water? Yes, HCl gas. So HCl gas is highly soluble in water. So how do you test, or what experiment shows the high solubility of ammonia in water? The same test that we had for HCl, that is fountain experiment. Okay, so in fountain experiment we have to take a big flask, inverted flask, and fill it with ammonia gas, and from down in a beaker we take water, and the color of the water should be red. Okay, red litmus solution we can say, and then there is a dropper in near the this flask, and when you squeeze the dropper which contains water, the reaction starts. Ammonia reacts with water to form ammonium hydroxide. Okay, it is called as liquor ammonia. Okay, ammonia and water is known as liquor ammonia, but the ammonia is highly soluble in water, so pressure is created. As a result of pressure, the water which is there in the beaker down goes up in the flask, and a fountain is seen. So here the fountain is in blue color. In HCl the fountain was of red color. Okay, so remember the color of the fountain. Just go through the experiment, fountain experiment. Okay, in the manufacture of ammonium hydroxide or liquor ammonia, and we know from fountain experiment that ammonia is highly soluble in water. Now, for obtaining liquor ammonia, that is ammonia and water, the same arrangement as we use for HCl, that is funnel arrangement, is used. Because ammonia is highly soluble in water, so we studied in HCl how the funnel arrangement is used. So if you go through those earlier videos, you'll understand what is fountain experiment and you'll understand the funnel arrangement used. I'm not been explaining this because it is there in that video. Please go through it. So funnel is kept in the inverted position. Down you have water, and from top ammonia is released. So it forms back suction, and then funnel arrangement avoids back suction, and then the ammonium hydroxide is used, and ammonium hydroxide is formed. Now, what is the use of this ammonium hydroxide? It is used for cleaning purposes. Have you heard about choline? Choline is used for cleaning the window panes. So what does choline have? Choline has this ammonium hydroxide, okay, which is liquor ammonia. The other type of use of ammonia is forming liquid ammonia. Ammonia is easily liquefiable. With about 8 to 10 atmosphere pressure, ammonia gets converted into liquid, and this liquid ammonia is used as a refrigerant, okay, because high latent heat of evaporation, okay. So when it has high latent heat of evaporation, what happens? It cools down the surrounding air and freezes it, okay. That's why this liquor ammonia is used. That is one of the other use of ammonia. Of course, there are many uses, okay. Now we will study about the reactions of ammonia. All right, now we study all the important reactions of ammonia. There are some 14 of them. You have to write and learn them, and see if you can write them without seeing the notes, all the equation, or you can ask someone to take it up, okay. So first equation is ammonia with dilute HCl. So ammonia reacts with dilute HCl to give you ammonium chloride. Now these are dense white fumes, you must have studied that. Then ammonia with copper oxide gives you copper plus water plus nitrogen. You should be able to write this equation as it is, the balancing and all. Now this copper oxide is basic oxide and it's black in color, and the product copper formed is brown in color. Nitrogen gas is evolved, that's why the arrow is shown upward. The third one is ammonia with lead oxide. Lead oxide is amphiteric oxide. It's buff yellow in color. When you heat it along with ammonia, you get lead, which is grey in color, with water plus nitrogen gas evolved. Now ammonia in excess with chlorine, very important equation. When you take ammonia in excess and you react with chlorine, then you get ammonium chloride plus nitrogen gas evolved. Ammonia with chlorine taken in excess. So when chlorine is taken in excess with ammonia, HCl, hydrochloric acid, plus nitrogen trichloride is formed, which is yellow explosive liquid. Now all the important reactions with ammonium hydroxide. Now ammonium hydroxide with dilute sulfuric acid gives you ammonium sulfate plus water. Ammonium hydroxide with dilute nitric acid gives you ammonium nitrate plus water. Ferric chloride plus ammonium hydroxide gives you ammonium chloride plus ferric hydroxide. Now ferric hydroxide is reddish brown and insoluble in excess of ammonium chloride. So remember, ferric hydroxide is reddish brown in color. The product, the arrow shown downward, shows that it is a precipitate, and the color of the precipitate is reddish brown and it is insoluble. Ferrous sulfate with ammonium hydroxide gives you ammonium sulfate plus ferric hydroxide. The ferric hydroxide is a precipitate which is dirty green and insoluble in excess of ammonium hydroxide. Then lead nitrate with ammonium hydroxide gives you ammonium nitrate plus lead hydroxide, which is a precipitate, and the color of the precipitate is chalky white and it's insoluble in excess ammonium hydroxide. Zinc nitrate with ammonium hydroxide gives you ammonium nitrate plus zinc hydroxide. Zinc hydroxide is the precipitate formed. Now this zinc hydroxide is white gelatinous and it is soluble in excess ammonium hydroxide. So all this while we were studying excess of ammonium hydroxide, it is insoluble, but zinc nitrate, when it reacts with ammonium hydroxide, gives you zinc hydroxide, and this zinc hydroxide is soluble in excess of ammonium hydroxide, and the color of zinc hydroxide is white gelatinous. Then copper sulfate with ammonium hydroxide gives you ammonium sulfate plus copper hydroxide. Now this copper hydroxide precipitate is formed, which is pale blue in color and is soluble in excess ammonium hydroxide. Now the same product, whatever is there, we take with excess of ammonium hydroxide. So in that case, copper hydroxide with ammonium sulfate plus ammonium hydroxide gives you tetraamine copper 2 sulfate. See the formula, there is a box bracket, Cu NH3 whole thing 4 SO4 plus 4 H2O. So it is tetraamine copper 2 sulfate. Alright. And the color of this will be deep blue or inky blue coloration. Now ammonium chloride, when you heat it, it's a reversible reaction, gives you ammonia plus hydrochloric acid. This dissociation is thermal dissociation. Ammonium nitrate, when you heat it, you get nitrogen plus water. So that gives all the important reactions of ammonia. Now we study all the uses of ammonia. So where all ammonia is used? It is used in the manufacture of explosive. Ammonium nitrate is used. In baking soda, sodium bicarbonate NaHCO3. Washing soda, sodium carbonate .10 water molecule. Urea, NH2CO NH2. Ammonium carbonate, NH4 whole thing 2iCO3. It's used in smelling salt. Smelling salt is used to revive a person who has fainted. Ammonium chloride is used in dry cells as well as medicine as well as in textile industry. Ammonium sulfate, which is a fertilizer. Then liquor ammonia and liquid ammonia. Sometimes we get distinguished between liquor ammonia and liquid ammonia. So what is liquor ammonia? As I have told you before, aqueous solution of ammonia in water is known as liquor ammonia. It is used as a cleaning agent. Then liquid ammonia is ammonia liquefied at low temperature. Now this liquid ammonia has high volatility, has high latent of evaporation, easily liquefies under pressure at low temperature. Hence it is used as a refrigerant. So sometimes you get a give reason. Liquid ammonia is used as a refrigerant. So you have to write these points, that ammonia is liquefies low temperature, has high volatility, has high latent of evaporation. So that means whenever it evaporates, it turns the moisture around into ice. Okay, so that's why it is used as a refrigerant. That's all we have for this lesson in ammonia. So if you have liked this video and understood it, please do not wait or hesitate to like, share and subscribe so that you'll get more videos of this kind. Now in the description box there is a link given. If you click on that link, you'll get notes on this lesson. Please do not forget to do written practice of these notes. Okay, that's all we have for this lesson. Thanks all of you. Bye bye. See you.